Good morning, students. Few topic we are going to discuss from the chapter Gravitation. The topic which we are going to discuss today is your number one, that is your Earth satellite. Now, let me define what is satellite. Basically, there are two kinds of satellite. One is your natural satellite and another one is your artificial satellite. Artificial satellite is nothing but man-made satellite. So, let me read out what we have written in the definition. A heavenly body revolving around the Earth in an orbit is called natural satellite. So any object which revolves around the Earth without using fuel can be defined as your satellite. So natural satellite is a heavenly body revolving around the Earth in an orbit. For example, moon you can consider natural satellite. Now man-made satellite is nothing but is your artificial satellite. So same thing. In artificial satellite also, the object which moves around the Earth without using fuel can be defined as your artificial satellite. There are many artificial satellites are there. INSAT 1A, INSAT 1B. INSAT is your Indian satellite. Basically, satellites are used for forecasting weather. Now, how can we launch a satellite? Now, if you want to launch a satellite, basically we are trying to define artificial satellite. What we have to do, you have to move from the Earth's surface and you have to reach a particular height where there is no gravitational force of attraction. Now, at that height, what you have to do, you have to impart certain velocity and with that velocity, the object moves with a constant velocity, you can say, around the Earth. And that can be nothing but the orbit of the satellite. So you have to raise the object from the Earth's surface at a particular height where there is no gravitational pull. If there is a gravitational pull, what will happen? The satellite comes back to the Earth's surface again. So you have to raise the object at a particular height where there is no gravitational pull. For example, this figure, you see the Earth is there whose mass is concentrated at its center. Earth is of radius, you can say capital R. Now you have to raise the satellite from the Earth's surface to a particular height, small h. At that point, what you have to do, you have to impart certain velocity to the satellite, and with that velocity, the object or the satellite moves in a constant orbit around the Earth. Now, there are a few parameters you have to define when you project a satellite from the Earth's surface. Now, the first parameter is your orbital velocity. At what velocity you will project the satellite from the height, particular height from the Earth's surface. Now, that is your orbital velocity. The velocity with which the satellite moves in a particular orbit can be defined as your orbital velocity. So, the velocity required to put a satellite into its orbit around the Earth is called orbital velocity. Let me repeat once again. The velocity required to put a satellite into its orbit around the Earth is called orbital velocity. Now, to define orbital velocity, here v is the orbital velocity. We have to consider this equation. Number one, gravitational force equal to centripetal force. Now, if you consider the satellite at a particular height, so force of attraction will be here G, capital M, small m by R plus H whole square. That is the gravitational force of attraction, and that is balances by the centripetal force. That's why we have said there is no gravitational force on the object, because that force is balanced by the centripetal force. Centripetal force comes out when an object moves in a particular circular orbit, then centripetal force comes out. So this equation we are going to use. So the equation for centripetal force is your mv square by R plus H, and small m is the mass of the satellite, and capital M is the mass of the Earth. So G, capital M, small m by R plus H whole square equal to mv square by R plus H. So on simplification, R plus H, 1 R plus H goes off, and V comes out to be a root over Gm by R plus H. Now from the definition of acceleration due to gravity, G equal to Gm by R square. Capital G is the gravitational constant, M is the mass of the Earth, and R is the radius of the Earth. So if you substitute Gm by Gr square, which is available in equation 3, So you will get v equal to root over gr square by r plus h. Now if we have to define the time period, because the object is moving in a circular path, so it has a specific time period. That time period is nothing but the circumference of the orbit. Circumference of the orbit is nothing but is your 2 pi r plus h, because the orbit is of radius r plus h. So 2 pi r plus h by v. So v already have calculated, that is your gr square by r plus h. So on simplification you will get 2 pi r plus h 3 by 2 root over gr square. That is your time period. Now from here you can define the height at which the satellite must be raised from the earth's surface, so that centripetal force becomes equal to the gravitational force, and that can be defined by squaring both sides. That's your t square equal to 4 pi square r plus h cube by gr square. So that is your equation, t square equal to 4 pi square r plus h whole cube gr square. So t square gr square divided by 4 pi r square r plus h whole cube. So r plus h gr square t square by 4 pi square to the power 1 by 3. So h comes out to be your gr square t square by 4 pi square 1 by 3 minus r. So h is the height from the earth's surface above which you have to take the satellite, and at that point you have to project the satellite with the specific velocity, which is nothing but the orbital velocity. Now if we have to calculate potential energy and kinetic energy, then potential energy at that specific point comes out to be your, as per already we have defined, U equal to minus G capital M small m by r plus h, and r plus h is the height from the center, and capital M is the mass of the earth, and small m is the mass of the satellite. So kinetic energy is your half m v square. So total energy is your potential energy plus kinetic energy. Now kinetic energy can be defined from here. If you take mv square, r plus h goes off 1 r gmm by r plus h. So half mv square is nothing but half gmm by r plus h. So you can use this equation number 2 if you want to substitute kinetic energy mv square. So on simplification you will get total energy is equal to minus half gmm by r plus h. So these are the specific parameter you must have to know regarding the satellite: the height, the time period, the velocity, the total energy. So probably you will get the numerical. So what you have to do, you simply have to substitute the values in the specific formula to get the result. Now most commonly used satellite is your geostationary satellite. So all satellite which we use is nothing but is your geostationary satellite. Now you see geostationary, what the name define. Stationary means it seems to be raised. It means if you observe the satellite from the earth's surface, it seems to be raised, because the time period is same as that of the earth, that is your 24 hours. So let me read out. The satellite which is at rest with respect to the earth is called geostationary satellite. And most of the satellite which you are using is your geostationary satellite, whether it is forecasting weather, whether it's for the security purpose. So there are many uses, and people used to go to the space also to repair the satellite. So please go through if you want to know more about geostationary satellite. So these are the equation, and probably in next class we are going to start the next chapter, that is your mechanical properties of solid. Please go through this topic and try to find out the doubt and see the revised syllabus. So if you have any query, please do ask and concentrate on the study. Thank you.